David Smith here with another flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. Today's lesson covers a statistical test called the chi-square test for independence. And a little bit about the notation. That looks like an x squared, right? Well, this is also the Greek letter chi, C-H-I. So this is a symbol for the chi-square test. So we're not doing x squared, so just don't stumble on that. You'll see this in this unit, and you need to remember that when we're talking about the chi-square test, it looks like the x squared test, but it's not. Okay, so let's put a context in this and talk about specifically what it's going to do. Then we're going to do a little vocabulary. Then we're going to do a calculation. Okay, so statistics. One of the uses of statistics is to make predictions about large groups or populations. So for example, maybe we want to make a prediction about what the average high schooler in the United States feels about, say, rap music. So what we do is we analyze a smaller sample of that population. We interview them or give them a survey, and we do statistics on that sample, and then we use the results of those statistics to make predictions about every high school student in the country. So that's what we try to do. Statistics allows us to say things about very large groups of people without actually talking to all those people. Or it could be about plants or any number of things. It's not just about populations of living things. So that's one of the big uses of statistics. Let's take a look. A certain question. Is there really a difference between 2 populations or 3 populations and certain attributes? Like, for example, is there a difference between boys and girls and liking rap music? In other words, if you ask a boy, do you like rap, it's a different likelihood than if you ask a girl if she likes rap. It would be different likelihood of getting a yes to that question, in which case there would be a difference between boys and girls with respect to liking rap music. So that's the type of question that we can ask. Here's an example, sort of similar. Is there a difference between females and males with respect to liking racket sports? So are males more likely to like tennis than females? Are males less likely to like pickleball than females? All those different sports that involve rackets, okay? And this is the example that we're going to work with in a minute. Okay, so the chi-square test helps us answer that question. And this comes back to independence. So is liking pickleball independent of whether or not you're a boy or a girl, or does the probability of liking pickleball depend on whether you're a boy or a girl? So if it does depend, then there is a difference between boys and girls and liking pickleball. Okay, a little bit more defining, vocabularying, explaining the concepts. So first off, what we do is we test 2 hypotheses. We use H, capital H sub 0 for the initial hypothesis. This is that there is no difference. So with respect to the example we're going to pursue, we're going to say there's no difference in terms of preference for racket sports between men and women. Okay? So that would be our initial hypothesis. It's also called the null hypothesis. And the idea is that if the null hypothesis is true, then there's no difference. H sub 1 is our alternate hypothesis, or perhaps the hypothesis we think is there. It's like what we think might be true. It's why we're doing the statistics in the first place. So this is the alternate hypothesis, and if this one's true, that hypothesis, there is a difference. Men like pickleball more than women do. So the odds of a person liking pickleball depends on whether they're a male or a female, okay? So 2 hypotheses, and our statistical task is to figure out which one is most likely true. So it's going to help us find which hypothesis the data supports. So this is where the stats and the data come in. You've collected some data. You want to find out, does that data support the null hypothesis or your real, or what the book is calling the alternative hypothesis? Okay? So here's the chi-square test where it comes in. If the chi-square test will show either independence or dependence. So if we have independence, it means the null is most likely true and there's no difference. So here's some verbiage to say that. Whether or not you like pickleball is independent of whether or not you're a male or a female. Doesn't matter. There's no difference. If it's no, then it shows that it's dependent. The alternate hypothesis is most likely true, and yes, there is a difference. So, with respect to liking pickleball, there's a difference between if you're a male or a female. Or to state it probabilistically, there's a different probability for liking pickleball if you're a male or a female. Okay, let's do an example. Here's some data. This data is organized in quite possibly the way it was collected. Somebody went around and asked people what their favorite racket sport was. And they kept columns for males and columns for females. And every time they asked a person what their favorite sport was, they wrote that sport down. So this line here represents one male who liked tennis. Same thing for this line. And then we had, looks like 5 in a row. Men said they liked squash. And then we had a badminton and so on. And the person collecting this data got 3 full columns of male responses. And also on the female side, they got these responses. Okay, so this is quite possibly the way this data was collected. So before we organize it, because obviously this is not organized, it's hard to even data snoop this data to find out if there's a difference between men and women with respect to racket sports. So we need to organize it. That's going to be on the next screen. But I want to show you something or talk about it. Notice how we have 6 fewer data points with the females. Now you might think that's a problem, that we should have equal amounts of females and males. However, the chi-square test for independence doesn't matter. As long as you have about 50 data points and enough of each population, you're going to be good. So let's go over and take a look at that. Okay, here's how we're going to start to make sense of all that data. So we make what's called a contingency table. And basically, we just need some counts. So we want to know all the males that listed tennis, badminton, and squash, and the same for all the females. So maybe scroll back in the video and pull up that screen we had, and go ahead and do your counts and fill in these spaces in the table and come right back. Okay, here's what I get. Counted them up, put them in my table. Now, to make the table complete, we need totals for the columns and for the rows. So go ahead, pause the video and do that. Okay, so I just made a row for totals and I made a column for totals, and I went ahead and added them up and did my math. Now, when you do this step, there's a check step. Once you've populated that all out, this plus this equals that, but so should these two. So the column totals should equal the total, as the row totals should equal the total. So you have a check for consistency. Now what we need to calculate is the expected values. And if you recall from our probability unit, the expected values are what you would get from straight up probability. If you did this enough times, this is what you would expect in a sample. So the way we get expected values in our scenario is we do the row total times the column total divided by the overall total. And that just gives you a straight up proportion. So referring to your table that we just put up there, the expected number of boys who picked tennis is going to be the row total times the column total divided by the overall total. So that gets us 10.45. So now I want you to pause the video and do the calculation for boys who choose badminton. Come right back. So here's my calculation for boys and badminton, 20 times 33 over 60, which comes out to a nice even 11. Okay, that would be the expected if there's no difference. So now that you've seen this calculation a couple times, I think you should be able to crank these out. We got 4 more. Boys in squash, girls in tennis, girls in badminton, and girls in squash. So pause the video and do those calculations and come right back. Okay, So here are the expecteds I get from doing that math the same way as that. So check your work there. If you made any mistakes, go ahead and dig back and make sure you did the right multiplications and divisions. Okay, time for our chi-square calculation. So check this out. On your calculator, now there's different steps for the 84 than the Nspire. The process is the same. And what you're going to do is you're going to put your observed data, your observed, in a matrix. The way to get there is a little different, but I'll have calculator videos and links below, and links also on our weekly planner and on the TI-84 click steps doc that I keep in our Google Classroom. So we're going to use a matrix and add our observed data. And so if you look at the table, you'll notice that these are how the numbers showed up. This row was boys, this was tennis, badminton, and squash. This was girls, tennis, badminton, and squash. So those are the observed numbers. Everything else in this problem is going to be a calculation. So all the calculator needs is the basic data. So you're going to go in there, enter the numbers in a matrix, and then perform the steps for the chi-square calculation. So what I'd like you to do is pause this video, go watch the appropriate video for your calculator, then do this step, put this in there and follow the steps, and come back when you have your chi-square result. Okay, here's what I get. My chi-square is 7.09 for this problem. Now we're going to do this a bunch of different times, different ways. You're going to get real familiar with that. There's more to say about what we're doing that helps us refine our answer to ultimately either have to accept or reject the null hypothesis and decide if there really is a difference between two populations or two groups. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that you didn't understand the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.